So let us start into this lecture today. So far in the previous two lectures, what we have discussed about the course introduction, objectives of the course outcomes, syllabus, how it is framed, what is each unit about, and after that one we have gone into the 8086 introduction when we have seen its features, followed by its architecture, and now in this unit we will be continuing our discussion of architecture, individual blocks in that bus interface unit and execution unit, and after that register organization is what we will be revising. So here is the bus interface unit. It contains a major three things. Okay, it has an address generator. The job of this address generator is very clearly we have discussed in our previous class while talking about memory segmentation, that here 8086 can address up to a 20-bit locations of address, but whereas it has only a 16-bit registers inside it. So to deal with this, what it does is that it cannot hold a 20-bit physical address into any of its internal register. So what it does, it takes the address split into two quantities, which is called as segment address and offset address. Together they are called as logical address. So segment address will be actually your top 16 bits of the segment starting point. Okay, when we take in hexadecimal numbers, the physical address will be of a 5-digit hexadecimal number, whereas the 8086 can hold only 4-digit hexadecimal numbers in any of its register. So top 4 digits of the segment starting address will be there in the segment register. It can be a code segment, a CS register, DS register, ES register, and SS register. Okay, they will contain, or any one of these 4 contains a segment address, depending upon you are accessing the code or the data. When you are accessing code, means program instructions, that time CS will hold the segment address and IP will hold the offset address. When you are accessing the data, depends upon what type of data it is. It is a random data, normal data, that time the DS, data segment register, will hold the segment address, and SI generally will hold the offset address. And in some cases, ES, extra segment register, will hold the segment address of the data, and DI, destination index register, holds the offset address of the data. And finally, the stack segment of memory, when it is used, that means wherever you are accessing the data which is in stack format. Stack format, again I can tell you, normal data formats here is the random arrangement. When anywhere it is there, anywhere you just go and just take that data and come back. But in stacked data format, it is not like that. The start data is placed one over the other, okay, as a stack of books in the shelf or something, where you can just access the topmost of it at that moment. So it will be a last in first out type of an organization, where you can access the last entered data at the first point. Okay, there are the two types of arrangements actually. Stack is one arrangement, and another is arrangement is called queue. In queue, whichever you entered first will exit the first, okay, or whichever you entered the last will exit the last. So these two type of formats of arrangements will be there. In memory, we have the arrangement of the stack data, but in bus interface unit, we have one queue also available, in which the instructions are pre-fetched for ease of access. Here, the instructions are pre-fetched in the format of queue. That means first instruction is fetched first, second is fetched next, third is fetched next, like that. And their exit from this queue will be first will go out, then second will go out, then third will go out, and like that, one after another. Whereas stack is different. Whichever enters last will be taken out first. Anyhow, this queue will be very helpful for pre-fetching the instructions, such that the ease of operation becomes easy here, or the working examples becomes very easy here. Bus interface unit contains instruction queue. About queue also I told you that they are used for pre-fetching the instructions, such that the speed of operation increases. Okay, talking about the execution unit contains of, again, 3 major things are there in execution unit. That is a general purpose register set is there. Okay, AX, BX, CX, DX. Then we have it, this ALU, which is, you can say, has a heart of a microprocessor. Here all the arithmetic and logical operations and string operations are handled. Okay. The operations what the processor can do is the data operations. It can manipulate data by doing arithmetic operations on it, by doing the logical operations on it, and it can handle the string data by manipulating strings. Strings, when we say, it's a collection of characters, and here what manipulations in the string you can do? You can insert few characters into the given string, you can delete few characters out of the given string, you can compare two strings. Okay, these all things you can do with the strings. So about the general purpose registers, about the ALU, and about the what you can say, this is about the control system in it. This control system is responsible for synchronizing all the internal operations. It synchronizes all the internal operations. So it gives the control actions. That means which job has to be done first. The ALU operation or the flag indications and activation of general purpose registers and so on. So that is what we have seen for all our classes. So thank you everybody. This is the end of our session today. Thank you.